Welcome to Vigyan Bharat. We are back again with another interesting video. Today I am going to discuss the problem for the day, which was asked in 16th April 2022. So the problem was, we are given three non-zero matrices A, B and C such that they satisfy this particular condition, that is A times B transpose is same as C times B transpose. So this holds for the given three non-zero matrices A, B and C, where of course this quantity denotes the transpose of the matrix B. Then we have to answer which of the following statements is true, that is correct from the given four statements. So let's see what we are given. In the first statement, we are asked that the rank of the matrix A is same as the rank of the matrix C. In the second option, it was asked that the non-zero eigenvalues of the matrices A and C are equal. Finally, AB is same as CB, and in the last option, if all the three are incorrect, then we have to go with the fourth option, that is none of the above is correct. So quickly, let's note down the given information. What we are given? We are given three non-zero matrices A, B and C, that is A, B, C are three matrices, and of course every matrix is non-zero. So it means that there exists at least one entry which is non-zero in them, and they satisfy this condition. So let me denote it by, suppose, say my 1. So AB B transpose is same as CB B transpose. Since the given problem in which we have to mark some particular statement, it is a MCQ kind of problem. So certainly there are some options which are not correct from the given statement. So we have to choose some counter examples in order to discard the given options. So let's move ahead one by one. So I'm going to choose some particular matrices A, B and C for which some condition don't hold, and then we're going to prove that that particular option is incorrect. So let me just change my color to blue for better visualization. Fine. So let me first proceed. What is given to us? We are given this quantity A, B, B transpose is same as C, B, B transpose. If I now move my quantity on the right hand side to the left, then what I get, just a second. So let's continue. There was some technical issue in between. So what I was saying, that if I take this quantity on the left hand side, then this equation reduced to this one. A B B transpose minus C B B transpose is equal to 0, where this denotes the zero matrix. But it denotes the zero matrix. And for the sake of calculation, I assume that my given matrices are square. Now using associativity, using the associative as well as distributive properties, associative and distributive property for matrix multiplication, I can rewrite the above equation, this one, as, first I can rewrite it as AB times B transpose minus CB times B transpose. Observe here I have used the associative property. Now I am going to use the distributive law, that is AB minus CB B transpose equals 0. Now, here, in order to proceed from this step, we should take a pause and think how can we proceed now. Since we are given that the matrix B was non-zero, so this implies that its transpose is also non-zero. This is pretty obvious. This is also non-zero matrix. Okay. Further, since this is non-zero matrix, and we know that this quantity, I don't know whether this quantity is 0 or non-zero, I don't have any idea. But I know that this is non-zero for sure. Maybe it might also happen that this is 0, this is non-zero. But one thing I can do, I can post multiply. I can post multiply the above equation by B on both the sides. This I can do for sure. So what I get? AB minus CB B transpose into B equals to 0 times B. And since B was a non-zero matrix, 0 times B will be a 0 matrix. The product of null matrix with any matrix, whether it's 0 or non-zero, is a 0 matrix. On the left, I get AB minus CB B transpose B. Okay. Now, if I take the transpose, because this in the bracket, this will also, again, after simplifying, it will go into a matrix of some order, because I assume that the given matrices of R square matrices. So, if I choose the transpose of this, if you see the transpose, so it will be this plus this. In general, we know that for any given matrix, suppose x and y, so x plus y transpose is same as x transpose plus y transpose. We know this property in general. So from here, if I rewrite it again, this will be B transpose A transpose. I'm using the property of transpose of a matrix, and this will be B transpose C transpose. If I now take the B transpose common, then I am left with A transpose minus C transpose. So I have already multiplied, what I am trying to basically construct, I am trying to write this matrix as some whole transpose of whole something. So it's now pretty easy. If I take the B common from, or let me just think what we can do. AB minus CB. And if I choose the B common, then it will be A minus C times B. Okay, nice. So, yeah. And if I now take the transpose of this, so the resulting answer would be this one. B transpose, and yeah, now it's good. So what I want now, again, you should take a pause and think what we can do here to write this as A minus C B transpose into multiply A minus C times B. I want an expression like this, because if I will be able to reduce this matrix in this form, then I can easily use a property directly, which is, first let me quote the property, that given any matrix A, it holds in general A into A transpose. If A into A transpose is the null matrix, then this forces that A has to be the null matrix only. The only choice for a matrix to satisfy this condition is the null matrix. Let's try to first prove this result in very short manner, since it implies this. So let me assume I'm going to prove this by a method of contradiction. Let us assume that A is a non-zero matrix which satisfies this condition, suppose. And further, I assume I could put a condition that its determinant is non-zero. If this is the case, this is a particular case I'm proving for, there may be other scenarios also. So this determinant of A is non-zeros, and this implies that A inverse exists. And we can now pre-multiply this equation on both the sides by A inverse, then it will going to reduce A inverse A transpose is same as A inverse times 0. The right hand side will be 0 matrix. This will be identity matrix. So this answer will be A transpose is 0. And if I to take the transpose again, then it will be A 0. But it is a contradiction to what I have assumed, that A is a non-zero matrix. So this is not possible for a non-zero matrix to satisfy the given condition. So therefore, from here we prove that A has to be the zero matrix only, and such a matrix, if satisfies condition, is said to be orthogonal matrix. You can prove this. This was a particular case for which I have proved. In general, if you want to prove this statement, choose some matrix A for some, suppose say 2 by 2. So A, B, C, D, where of course A, B, C, D are coming from R. Then you prove taking that it's transpose. It will be simply A, B, C, D. I have taken transpose. You multiply these two, then you will get some equations in A, B, C, and D. Solve these equations, and you're going to find the answer that your A is only the zero matrix. So this you have to prove. I leave it to you. Now I come again back to this equation. Here we was. So wait just a second. We were here. Here we were. From here we multiply by B, and we came to this one. If again we see what my objective is, I want to reduce this one to this one. So now let's see what we have to multiply with. We already have this quantity. This quantity is already there, AB minus CB. This is here, this quantity. And what I want to transpose of this, and B transpose over there. Okay. So we have to multiply, post multiply basically, rather than by B, we can multiply by, from here we can multiply with this factor A minus C times B, and of course it's transpose on both the sides. So the resulting equation will be this. You have to do that step by post multiplying with this transpose on both the sides. So directly I am now writing this, what we got, A minus C into B transpose, A minus C into B whole transpose times A minus C into B equal to the null matrix. Because we have just proved the property above that in general for any matrix A, this holds. So from here you try to see this whole as a A matrix, and its transpose of course, and this. Okay, just wait. Now I got what the mistake we have committed. We want to transpose on the right hand side, but it will hold again because the transpose is here, but I have constructed the transpose on the left. So I left it to you, simply post multiply and you will get the answer. So here, from here, what we got, that this A minus C times B is 0, or AB minus CB times 0. This implies AB same as CB. So from here, we proved that this is the correct option. Now, what I am interested in, not only proving the correct, but also to discard the incorrect option. That is also equivalently important for us. If I can discard the incorrect option, then it's a easy route to choose the correct one. So let's, now we know that this is a correct option, so certainly we have to prove that this one is incorrect. So for this, I have to choose two matrices. Let me do it here. So let me choose my A to be, suppose say a 2 by 2 matrix, which is, suppose I have noted down 1 0 0 minus 1. I have chosen my B to be 0 0 1 1, and C to be this one. These three matrices I have just noted down, and like I created this example, and it worked fine in our case. So now using these matrices, we have to prove that this condition hold. You can easily check. I left it to you to check that A, B, B transpose is same as C, B, B transpose. You have to check yourself. Now from here, if you see these matrices, the rank of the matrix is already in a natural form. So there are two entries, non-zero entries and diagonals. So rank of the matrix A is true, while rank of the matrix C is 1. Only one non-zero row you can approach in this number. So rank of the matrix is C is 1. So certainly this is an incorrect option for us. Now the second statement is the non-zero eigenvalues of A and C are equal, but this is not the case, which is straightforward again. If you see, the eigenvalues of a triangular matrix lies on its diagonal. We know. Suppose in general we have a matrix like this: A, B, 0, C, or A, B, 0, C, like this. These two are triangular matrix, whether upper triangular or lower triangular. So in this case, if you use the Cayley-Hamilton and find the characteristic polynomial, then the eigenvalues will come out to be entries of the diagonal A and C, A and C. These will be your eigenvalues. In our case, the A matrix is this. So the eigenvalue is 1 and minus 1. There are two non-zero eigenvalues for the matrix A, while for the matrix C, there is a 0 eigenvalue and a eigenvalue which is minus 1. So the option says that the non-zero eigenvalues of A and C are equal, but it is not the case again, because the non-zero eigenvalue of A are 1 and minus 1. There are two non-zero eigenvalues, whereas for the option C, there is only one non-zero eigenvalue which is minus 1. So you're also able to discard this option. So like this, we have solved the given problem. Try to prove that result which I just left after the particular case. I left it to you to prove that. So now I tell you where this problem was asked. It was asked in ISI Kolkata entrance test. ISI Kolkata M.Tech CS, M.Tech Computer Science entrance test, and the paper was in 2020. I guess you check either 20 or 21. So this problem appeared in their exam. So we solved the problem finally. So there are two important informations for you. For the first is that in this particular series, like, we are posting a problem every day on our Telegram group, on our Facebook page as well, and across Instagram also if you are there. So for a convenience, if you join our Telegram group, so it will be going to be very helpful for you, as in addition to the problems, I post some information regarding some conferences, seminars related to mathematics which are happening in our country, and we also have some good discussions there on these problems as well as other problems. And second information I want to like, if you like the video and find it to be useful, then please do like it and subscribe the channel by pressing subscribe the channel, press the bell icon for receiving the notifications at the earliest. And thank you so much for watching. We'll meet again in a similar video. Thank you so much for watching.